So I'm Keisuke Hirata, security consultant at NCC Group. And so today we are going to talk about automotive security assessment. And so previously when I was based in Japan, I used to focus on automotive security. I was performing a lot of pen tests for cars, whole vehicles, and also single unit automotive components. And I think that automotive security is still a relatively recent topic. There are less established techniques and publicly available information compared to other areas of cybersecurity. And so that's why today I would like to share with you some of the techniques I was using, some good tools to use for pen testing, and also discuss with you some of my own observations that I had during my experience. And so for the agenda, we will start with a presentation of nowadays connected cars to give you an idea of the attack surface of a car nowadays. Then I will briefly go over some security assessment techniques for different technologies. And after this, the rest of my talk will focus on the in-vehicle network techniques. And to finish, I will give you some examples of how these techniques can be used in a real pen test. So here is the attack surface of nowadays connected cars. So in today's cars, there can be up to 100 parts called ECU, which contain a microcontroller. And the number of lines of code can amount to 100 million. So a car is not just a mechanical device anymore, and it can really be seen as a computer on wheel. And in nowadays connected vehicles, a lot of new technologies were added to increase their connectivity. And so attacking a car used to require a physical access for connecting to the in-vehicle network. But now with the use of wireless technologies, the attack surface also includes remote attacks. And also, there are new services that are appearing around all the data that can be collected inside the car. And so, for example, the data can be used for emergency services and also for insurance companies. And that, again, increases the attack surface. And so, all these different attack vectors make the problem of securing a car a really complex challenge. And this is why I think that automotive security is so interesting, because this diversity of technologies required us to develop a lot of different techniques for each of these technologies. And so now I would like to present you some of them. So I will start by USB. So now inside cars, in the infotainment system, you can find some USB ports sometimes. Sometimes it's a bit hidden, so you have to dismount the infotainment system a bit and look at the system just behind for ports. So for testing this interface, we use an open source hardware for emulating USB devices. And then we enumerate what devices are supported. And in the next step, we fuzz that interface by providing some malformed files. We have seen a lot of bugs inside the USB drivers of the system, so this is a really interesting thing to test. One other interesting thing that we saw was that sometimes when the infotainment system crashes, it dumps some crash logs and some debug information inside the USB drive. And this debug information is not encrypted, and you can really get some valuable information during a pen test from USB. So now Bluetooth, and so now in most cars you can use Bluetooth to pair your smartphone with the car to be able to make some phone calls or to listen to some music. And Bluetooth is an interesting attack vector because it is a remote one, and it allows you to communicate with the car remotely. So for testing this technology, we have a tool called BlueShift that was developed, and so it allows for scanning all the sub-protocols of the Bluetooth specification. And what we can do with that tool is also to find some vulnerabilities in the pairing mechanism. So by using such vulnerabilities, we can pair with the infotainment system without knowing the input pin. Another interesting attack vector again, infrared. In some cars, the infotainment system use infrared signals. So once we're in a situation where we were testing a car with an infotainment system which could be controlled with a remote control by sending some infrared signals. And also what we saw on that car was that there were some externally exposed CAN wires on the car. And the thing was that when the car was turned off and locked, the CAN bus would turn into sleep mode, so we were not able to communicate over the CAN bus anymore. But what we did was to replay some of the infrared signals, and that actually woke up the infotainment system, which then woke up the CAN bus, and then we were able to send some CAN messages from these externally exposed wires. So this was a really interesting attack vector to exploit. And yes, so now for the rest of the talk, I would like to focus on the in-vehicle network techniques. So the main in-vehicle network is the CAN network. And so it is the network that is connecting most ECUs inside the car, most of the safety critical ones. And it can be used for controlling all the physical functions of a car. For example, for controlling the steering wheel, the brakes, or the acceleration pedal. So it's really a safety critical part of the car. And this CAN network can be accessed from a physical port inside the car, which is called the diagnostic port. So it is a port that is used by car dealers for performing diagnostic routines, diagnostic assessments. And so usually for accessing the CAN bus, it was required to have physical access to the car and then connect to that diagnostic port. But now there are a lot of ECUs that are added on this CAN network, which have wireless technologies that are enabled, for example, telematics systems, infotainment systems. And so now what an attacker can do is to first attack wirelessly the infotainment system, and then from that point jump into the main CAN network for attacking physical functions. So as the CAN network enables to access the safety critical function of the car, it is really important to secure that part. And technically speaking, the CAN protocol is quite simple. The messages are only 8 bytes long, plus one identifier of 29 bits or 11 bits. But actually, when you look at the CAN traffic, it can seem quite complicated. So here, it is a video of a CAN traffic that I monitored with a tool called CAN Sniffer. So I will show you how the traffic can look like. So yeah, so here is an example CAN traffic. So for each line, there is only one ID that is output. So it is regrouped by ID, but still you can see that there are a lot of different CAN messages that are on the traffic. And this is because there can be up to 100 ECUs connected on the CAN bus. So it can really be complicated to reverse engineer the CAN traffic and then find some attacks. And the problem for reverse engineering these messages is also that all the data that is exchanged between the ECUs on this network are following manufacturer-specific protocol. So you don't really know the meaning of the data because there is, of course, no documentation available. There's no open source code. And and you can't see things such as parameter names or ASCII strings. And so the reverse engineering part can be really difficult. And so that's why I would like to talk to you how information can be gathered to try to understand the meaning of all this data that is exchanged. And for this, I think it is important to understand first that the automotive world is a complex ecosystem where many actors are involved. And to regulate and improve these processes, many standards and requirements were created. So for example, in the automotive industry, the OEM will give requirements on the components of their suppliers. Governments will create laws and requirements that will affect the technologies used. And there are also some alliances and partnerships which work for standardizing the technologies. And so that will give us a lot of valuable information. And yes, so here are some example laws and technology standards that can be useful. And yeah, they are really interesting because they have an impact on the requirements for the software and also the hardware of the automotive components. And so now, in the next step, I would like to show you how information collected from these documents can be used at each step of a pen test. So I will start by the discovery phase. So for this step, so the most useful standard is the UDS standard. It's a protocol that is used by car dealers for diagnostic purpose, and it is done over the CAN network. And there are really interesting services that are defined in this standard, such as the memory services. So there are services that allows you to read or write on the non-volatile memory of the ECUs. There are also upload, download functions. And yes, one other interesting thing is that this UDS standard is quite widely adopted. So you can use it in many cars, many different cars constructed by many different OEMs. And so for requesting these UDS services, the first thing you need to do is to scan for the address of each ECU. And for this purpose, the ISO-TP standard is required and can be used to gather information because it defines yes, which CAN ID, how the addressing will be performed inside the CAN network. And so you will know which CAN ID you have to monitor for responses to your UDS requests. And also in the UDS standards, there's something interesting defined, which are the response codes. So here in this table, I listed a few of them. And so this response code can be used for scanning ECU addresses and also for scanning available services. So we are using a tool called vmap that does all this enumeration. So it loops through the UDS addresses, services, and look for the responses from the ECUs and their NRC code. And it also loops through the sub-functions and to enumerate if there are some hidden services available. Even more information can be obtained from this standard, this UDS standard. So there's something called the NRC handling sequences, where the priority of the NRC will be defined for each service. And this is really valuable information to use when reverse engineering, because the NRC gives you information on which parameters are incorrect inside your request. And also with this diagram, you can try to reverse engineer the parameters step by step. You will know which condition is not correct. So this, again, gives valuable information. So here are some observations that I had. So the UDS standard is not always strictly followed. So it is also important to go beyond what is really defined in the standard. So for example, some NRC replied are inaccurate. Some uncommon subfunction values can be found. And also, there are other diagnostic protocols than UDS. So for example, General Motors is using the GMLAN standard, which is quite similar to the UDS standard, but there are some different services which has different parameter values, for example, and there are also interesting concepts such as broadcast address, which can be used for improving your scanning phase. So now, after you finish your discovery, what you will want to do is to go further in the systems, in the ECUs, and possibly obtain some firmware. So for this step, the websites hosted by the OEMs can be used, for example. So the OEM make available website for car dealers on the internet, and they contain really valuable information. For example, repair manuals can be found. So these repair manuals give information about the physical structure of the car. It can also tell you how to mount and dismount parts. And sometimes it can contain schematics, pin layouts. So this is something to use if you want to do some hardware hacking of a single component and then extract some firmware, for example. And yes, this website are also used for downloading firmware, software patches, but it generally requires a diagnostic tool. So here is one example of an OEM website. So this is the one of General Motors. And it gives a lot of interesting information about the software. So for this website, you just have to input the VIN number of your vehicle, and then you will get a list of all the parts inside your vehicle, the software version numbers, and history of all the components inside your car. And you can combine that information with the read data by ID diagnostic protocol, because this diagnostic protocol requests to all the ECUs inside your car to give you back their software version number. So that software version number information can be crossed with the information that is on the website, and then you can possibly detect some outdated software, and also helps you figuring out which ECU is behind each address. So after you obtain a ECU firmware, the next step will be its analysis. And so first, I would like to start with some observations. So I saw that a lot of pieces of software are often reused by suppliers for different OEMs. So that means that a same software component can be found in different components for different manufacturers. And a lot of the firmware that you can get is not encrypted, so you can reverse engineer it. And sometimes some valuable debug strings can be found. So for having hints when you're performing firmware analysis, I think the AUTOSAR standard can be interesting. So it's a standard that defines a software architecture for the firmware inside the ECUs. And what is interesting is that it defines the functions that has to be implemented for each module. And it defines also the names of the functions at each interface. It's quite similar to an API. So here is one example from the standard. So you can see that you have quite detailed information. You have the function name, the prototype, some documentation about the parameters that have to be used. This is another example. So here we have a sequence diagram for one function, and it tells you basically how the function has to behave, and what is the logic flow of the function. And so I think this kind of information can really be helpful during a firmware analysis, and especially because, as I said, some debug strings can be found, and you can find sometimes function names, and so then you can cross that information with the AUTOSAR standard to understand better how the firmware behaves. So conclusion, what I would suggest for approaching automotive components is really to look at the standards and requirements that are done for each country, laws and requirements, and also from each OEM, from each consortium. But it is also important to keep in mind to not restrict to these standards, because as I said, there are a lot of manufacturer-specific things, so it is really important to go beyond these standards. And yes, and finally, OEM diagnostic services that are online can really provide you a lot of useful information, and is something really interesting to look. So, Q&A.
Hello. How did you find General Motors programming website?
It is available online, so if you search a bit, you can find it. And actually, for that slide here, that gives you software information. You don't even need an account for using that service. So you just enter your VIN number. You tell for which part you want to have information, and it displays this.
Only General Motors?
Yeah, this is for an example from General Motors. So yeah, for General Motors, you don't need, it's available on the internet.
What is the situation about other?
For others, usually you require to have an account or to be a genuine dealer, car dealer for that OEM, usually. But yeah, the same kind of information is contained on this website.
Hi. Have you ever tried to modify the firmware to like do whatever you want?
Yes. So yes, it is possible to modify the firmware, for example, by using the UDS services that are presented. And actually, this is how all the firmware updates are performed. They use UDS services to transfer the data, and that will modify the firmware inside the ECUs.
So there is no integrity check or other things?
There are, sometimes it depends, yeah, some integrity.
So you bypassed?
Yeah, you have to, you need a bit of reverse engineering, a lot of tries, and yeah, you can.
I have one more question. So, when I also have looked at vehicles, and so in some cases, the vehicle, if we send some like invalid messages, packets to the ECUs, then sometimes it like breaks the whole vehicle. Have you ever experienced that?
Yeah, it is true that there are some UDS services that are quite dangerous, but I never actually broke a car, but I had some error messages displayed on the dashboard, things like this. So yeah, all these things have to be really done carefully, because you can really modify your car, break it. Yeah.
So do we have any more questions from the floor? If no, then thank you. So we'll be end of the morning sessions, and our afternoon sessions will be start on 2 p.m. And for all the paid delegates, conference delegates, you can enjoy your lunch at the cafe of Ash and Elms. Thank you.